Bad news. I believe this is section 3 of the Bicycle Tech pedal-powered truck on Mars. And my thoughts were leading towards having fixtures that are machined out of cast aluminum to act as a machined framework for a pressure vessel. But that pressure vessel does not have to be all aluminum. It doesn't even have to be all one piece. It can be welded, it can be sealed, a lot of things can be done. So, one thought is that assuming the spacesuit will be bulky and will be of such design that a person can take one on and off by themselves, and you work out how much space you need to do that, that plus 20% or so gives you your wheelbase of your axle in the back end. So directly above that, you have the bed, the design of which would be tubular metal of the alloys popular in mountain bikes, and bicycles and 10-speeds. And of course some engineering thought would have to go into which one do you want to use, because you generally want to use as much of the same stuff as you can so that you don't have all this complexity of can I weld this to that. So I would nix magnesium right off the bat, just because it has to be human rated space, and just kind of get obsessive about safety stuff so stuff don't blow up. All right. So this bicycle, or actually quadcycle, would be like a bicycle frame extended out into something similar to the drivetrain of Toyota two-door pickup from the 80s, long bed, and have, instead of the heavy cast steel that you see in the frames of cars here on Earth, or a pickup like that, you have a very light tubular bicycle type engineered frame with lots of flexible or joints and compressible rods, so it can take pressure impacts from all kinds of directions and survive. And you use the fat tire, but designed like the NASA lunar rover, or similar ideas, to make sure that you can actually run that wheel in that very low pressure, very different kind of environment with a lot of abrasion and abuse over a long time. Let's take a look at how many minutes I've got on this. I can't really tell. Oh, 3 minutes. I'm not wearing my glasses. And then on the inside of the bed, you use thin sheet metal of the type that you use in air vents here on Earth, with a little bit of extra support built in. There's several ways to do that. One is to actually use the sheet metal stock itself and cut long tapered triangles and fold them 90 degrees from the shortest angle, where the other two angles side by side to that are of a very they're equal, so that you have like a stretched equilateral triangle, but only in that x-axis. And you fold that along that center line, and then take a half-inch parallel to the flat of the current, and you make a little strip. It's a 1/2-inch strip on both sides, like a shelf bracket. And you fold it like that and tack weld it onto that sheet metal, and seam weld everything to the frame, and you have an airtight surface. And on top of that, you can put other materials, like you can put deformable foam of some sort that returns to shape, like foam rubber or such. Not quite styrofoam, but something that actually you can compress it all the way down and let go, and it goes all the way back. And has good extremes of temperature data on it. And put another sheet of deck material, like hardwood flooring made out of bamboo, real tough stuff, right? And you put that on top of that, and it'll float on top of that. And if you seal it all up right with rubber tape of a type designed to kind of flex side to side and back and forth, and compression and stuff, in all the seams, you should be able to make a reasonable pressure vessel. If you take it up, if you put it in a vessel that can give you the Mars atmosphere temperature ranges and humidities, and you run the internal pressure up to sea level here on Earth, you should be able to test to see if things break, if they leak, if the pressure requires too much extra adding of gas to pressurize. And the rest of the frame would be kind of big windows that you'd have to fill with something to hold back that air pressure in those areas. And what I'm thinking is actually 1-inch plexiglass 4x8 sheets, off-the-shelf product, kind of expensive, but pretty cool stuff. And if you kerf all the edges and all the corners, and you kerf the corners, you kerf the long edges a 1/4-inch kerf, and you put a 1-inch kerf on all the corners, and blend that into the long edges where those two kerfs meet. And then you mount it with clamps into a vacuum table that creates a bubble-like bulge on a shape kind of like a bathtub. If you assume the 4x8 dimensions of the extreme edge of this plastic plate, you come in from the side to an ellipse, maybe even with kind of smooth, truncated ends, so that fairly uniformly most of the edges will be dead on, say, 4 inches. And the rest will be that ellipsed bubble. And you can set the depth of the bubble to what you figure is really going to hold pressure, not be too outrageous and bump into things, a real reasonable dome height dimension. Call it, I don't know, let's call it 8 inches. It should come out almost like a half a cylinder if you do it just right, with kind of roundy ends, which would work really good for the sides and the roof, and a flat plate in between. Well, the front plate could be a straight bend, give it some curvature, kind of like a car windshield has a side-to-side bend. I'm going to check the time on this, and I really can't see it. Looks like 8 minutes. I'm going to start a new chapter of this in a minute. See you soon. Part 4. End of part 3, beginning of part 4.